So we have seen this
This call
slide,
is now being recorded.
this slide, and this we have completed, and the list versus NumPy, the basic differences and all we have seen. And yeah, so here we have basic array operations. Okay, so let us first check like how to create an array in by using NumPy and all. Like we already created it, we'll just see the code once. Okay. I'll open my Jupyter notebook. Okay, in session 2. Yeah, so we have created NumPy array by using this particular syntax. By using the array is a method present in this NumPy package, and we are using that array to create an array by using NumPy in Python. Yeah, we are clear till there. We are very clear actually. Okay, so if I want to use NumPy, I need to import my package, right? So you don't need to import multiple times actually. You can import it once at the top, then automatically that will be followed throughout the program, right? Okay, so yeah, so instead of this import NumPy, like we can give some alias name to it, like a shortcut name to it. Why? Because see, sometimes the package names would be like contains like more than 10 letters or 11 letters. Then it becomes an issue for us, like every time we have to write the 10 letters and 11 letters by mentioning that package and all. It's very difficult for us to memorize or write such kind of things. So for that, we can create some shortcut names by using as keyword. Okay, as np. I'll write down numpy as np. Now instead of numpy.array, I'll simply use np.array. Okay, np.array, and will print a. Okay, yeah, so like this now you can give shortcut names to any packages, to any external packages you are importing now. So the packages, while importing only, you can give some shortcut names to it, and you can use that shortcut name throughout the program. Okay, I've executed this. See, so it has worked perfectly. That means I can use some alias name also. It will execute the NumPy package perfectly. There is no error now. So you can use shortcut names also, right? So we'll see some array operations. Like we have seen D type. It gives us the data type, the elements present inside that array. No? It gives us that particular data type. Okay, the second thing is size. You already seen it. The size gives the length of the entire array. So how many elements are present inside that array? And shape of array. See, shape of array. Okay, we'll see. What do you mean by shape? Shape in the sense like how many rows and how many columns are there? If only one column is present, how many elements are there in that particular array? It will give us. Uh, Please mute now. Okay, good. Okay. So let us see. So I have created one array. You can call this as a matrix as well because it contains 2 rows and 3 columns, right? So 2 rows, 3 columns. Okay, I'll use a dot shape. See, 2 by 3. So the same way how you represent matrix, no, m cross n. That's the exact logic here. So 2 by 3. So 2 by 3 is the shape of the matrix that we have created. So that means if you are creating multiple lists inside an array, that becomes a matrix. So if you are creating only one list inside this array, that becomes a 1 minute. Okay, I've given one more extra square bracket. See that becomes one vector. So we all are aware of vectors, right? So vector is a single dimensional data point which is stored, and matrix is something, it's a multi-dimension, like it contains more than one dimension. That is, we use rows and columns for matrices, right? Yeah, so you can create a matrix by like giving 2 lists inside this NumPy array. And if
Sir,
I
voice
run
is
this
not
out,
clear.
okay, how about now? Is it clear?
It's clear, sir.
Oh, okay. Yeah. Uh, yeah, so that's how you create matrices, no? Matrices or vectors, by using numpys. But if you use lists and all, no, it doesn't give you that matrix format, like m cross and rows and m rows and n columns format. It doesn't give you. So that's why numpy is best suited for storing data like in rows and columns, And yeah, so in rows and columns, and you can perform operations very well on that matrices. Okay. Okay, that's how the shape is. Okay, so we have zero matrix as well. You can create zero matrix by using this syntax, np is dot zeros. Np is the shortcut name which I have used now. So np dot zeros, it creates an array of zeros. Yeah, you can call that as matrix as well, that's okay. Like it creates an array of zeros. Let us see how it creates. Okay, np dot zeros, and I need to provide the shape of it. Like the shape of it is 3. I mean, whatever the shape you want, no, you can give it. So see, it throws us the array with all the zeros with 3 rows and 3 columns. Yeah, that's how you can create zero matrix as well. If you want to create the matrix with only ones, you can directly use np dot ones also. See, it creates a matrix
Sir,
or an
voice is
array.
not clear, sir. Sir, voice is
Uh,
not clear.
okay, okay, hold on. Is everyone facing the same issue?
Sir,
No, sir, it's clear.
It's clear for us.
Yeah. So Abhi, I guess you are having some connectivity issues. Check it out. Okay. Okay, yeah. So in order to create a matrix or an array with only ones, now you use np dot ones as well. Remember, guys, whatever the ones or zeros we are using are the methods present in that particular package. Remember. So for strings you have different methods. For lists you have different methods. For dictionaries you have different methods. There are different methods for each and every functionality. Okay, I mean, like for each and everything, like for data types you have methods, and now for packages like numpy and all also you have methods, and you're using those methods to create something. Okay, and the numpy package is very much useful while dealing with data science projects. So people come across this numpy, they come across this regularly on this numpy and all. So data science, while learning data science, you need to understand like the operations done by numpy and all. Okay, the next thing, np dot zeros we have given np dot a range. So range function we have already seen it. It works in the same way. So np dot a range, it's like it takes a range of elements and it prints out. If you want to print it out, if you want to store, you can store or print out that particular range of numbers. Okay, let me see, np dot a range of 1 comma 10. See, it has directly printed out my an array with numbers ranging from 1 to 10. Yeah, the np dot a range function does that job. And next thing, next operation is np dot lin space. So okay, okay, so np dot lin space is something, it divides the distance between the points equally, equidistant, like whatever the distance you want to give between the points, no, it divides that. Suppose 1 comma 10, I want to divide it by 2 with an equal distance of 2. Okay, hold on, I guess oh, sorry. Yeah. So np dot linear space is something. Yeah, I got confused. Yeah. So np dot linear space is something where it divides the numbers into that many quantity whatever you give. Suppose if I give 1 comma 8, if I give 1 comma 8, and if I give like 5, so it divides the numbers equally. It gives us the 5 numbers, and which are divided equally. The distance between each number is same. So that's how the alliance space, the functionality works. It divides the numbers from 1 comma 8, it takes the numbers and it divides the numbers accordingly. With it divides 5 numbers, we are giving the 5 number here. The third parameter is 5, so we are giving 5 number here. That means it divides the elements or the numbers present in between 1 comma 8 into 5 numbers, and which are equally divided. That means if you identify the distance between this and this, it's the same. If you identify the distance between this and this, it's the same. So it goes with the same distance and it gives you the numbers. Linearly spaced numbers generation. So linearly spaced, the distance between the numbers are always same. So that is called as linearly spaced. Okay, and next thing, next one is a dot reshape. So reshape, it reshapes the matrix or the array. So we already know, like we have done some transposes in the matrices, if you remember, like transposes or changing the shape of the matrix and all, kind of, right? So now in by using Python also you can do that, like you can change the shape and all. So how to change the shape? Let us see. So let us consider this matrix only, or the array. I'll copy this. Yeah, so 1, 2, 3, 4, 5, 6. So is my matrix with 2 rows and 3 columns. Okay, with the 2 rows and 3 columns. Now I would like to change the shape to 3 rows and 2 columns. Reshape. See, so the entire array is reshaped into 3 rows and 2 columns now. Okay, so if you want to reshape it to like any number, like if you want to reshape the size of that array, no, you can do it. But understand, like there are only 6 elements present in the array. See, since we have 3 rows and 2 columns, that means if you multiply 3 into 2, automatically you'll get the number of elements present inside that particular array. So we have like 6 elements. So the combination, it should be like if you multiply the rows and columns, it should be 6 only. If the rows and columns, if you want to reshape or going out of that 6, then it doesn't work. It doesn't reshape because it can't create new columns or new rows based upon your initial construction of your matrix only. It takes that into consideration and it reshapes it accordingly. Okay, for example, so if I want to reshape it to 6, 1, I can do it, right? Because 6 into 1 is 6. See, if I want to reshape it to 1, 6, I can do it. 1, 6. Okay, but what if you want to reshape it to like for example 4, 3? It will not work, right? Because cannot reshape array of size 6 into shape 4, 3, because the shape 4, 3 fits 12 elements. That is 4 into 3, 12 elements. But we are having only 6 elements in picture. So when you're having 6 elements, then the combination output, whenever you multiply the x and y, the combination, whenever it gets the 6 value only, it reshapes that. If not, it will throw you an error because it cannot create any new rows or new columns or new values. So how many values you give it, accordingly you need to reshape your entire matrix. Okay, a dot ravel. So ravel flattens the array, so it directly converts everything into a single dimensional array actually. See, it has converted everything into a single dimensional array. That means, oh yeah. Okay, and next a dot minimum gives the minimum value in an array, same like the list and all, no? So if you type a dot minimum, it will give you the minimum value. If you want a maximum value, you just give a dot max, so automatically it gives you the maximum value. And a dot sum adds all elements in an array. See, same thing, like if you use a dot sum, same operations. What are the operations you have seen in the list and all? It does the same. So it adds up all the elements and it gives you the respective output. Okay, but here, see, since we are dealing with n dimensions now, like more than one dimension, so you can add up the rows separately, you can add up the columns also separately. So how to do it? So you take this function, you give the parameter as axis equals to 0. Like you need to mention the parameter here now. So already we have dealt with functions and all. So now you already know what are parameters. So axis is a parameter for this functionality. And if I use axis is equals to 0, it adds up all the column elements. Let us see. So what do you mean by column elements? See, okay, first we'll print this. Okay, so see, columns or from the top to bottom, these are the columns, like 1, 4, 2, 5, 3, 6. So it adds up all the columns actually. 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 6 is 9. Okay, so we'll see we'll check a dot sum, and what is the parameter? We have axis is equals to 0. See, it is adding up all the column elements. If you want to add up all the row elements, like 1, 2, 3 is one row, 4, 5, 6 is one row. So if you want to add it, simply you give axis is equals to 1. See, 1 plus 2 plus 3 is 6, 6 plus 5, 11 plus 4 is 15. So if you want to add up all the column elements, give axis as 0. If you want to add up all the row elements, give axis as 1. That's it. Okay, you can also identify the square roots inside of each and every element present inside that array. Okay, so it's very easy not to identify the square root. you simply give the package this thing and sqrt and np.sqrt of a. That's it. See, so the square root of 1 is 1, the square root of 2 is 1.414, the square root of 3 is 1.732, and so on. So you can directly find the square roots also. So why, you see, why there are these many mathematical operations in NumPy? Yeah. So while dealing with data, remember in the first session, while introduction part of our data science, I told you we need to clean the data. I told you after discovery of the data, we'll clean the data, right? So while cleaning the data, now we'll have so much of noise. Usually we'll have so much of noise. So how much the garbage you're sending it into the machine, the output will be also garbage. So we need to clean the data. So while cleaning the data, now we use some mathematical functions or some mathematical functions or like logarithms, exponential, square roots, to reduce that noise and all accordingly. Like we'll have some certain steps according to your data and all. You need to apply that particular mathematical logic. Remember this statement, because once the data science starts now, you'll you'll come across this only, like canceling the noise, canceling. I'll be keeping on telling you while cleaning the data. We'll cancel the noise and all. Remember that. Okay. So you can, yeah, arithmetic operations are also done very easily. So arithmetic operations like multiplication, addition, subtraction, and division. Yeah, for example, we'll take this array. And we have created one array, and we'll create one more array. Okay. Yeah. So now if I use a plus b, see, it is adding up the elements actually, if you clearly see. So previously when you sorry, a plus b, yeah, the same output only. Yeah. So previously, while adding up the list and all, it concatenates it. You remember, right? Like 1 2 3 comma 4 comma 6, 4 comma 5 comma 6. It concatenates the list actually. Here, it is adding up simply. So NumPy is mostly used for mathematical operations. Like if you want to add up or use logarithms or use exponential terms or anything, NumPy supports that. So you use NumPy for good mathematical operations. Remember that. Okay, and then slicing. So previously, what we have seen was a single dimensional slicing. You remember, right? How the slicing is done and all. But here now we will do like a slicing for higher dimensions also. Like since we are having rows and columns, we can do slicing for rows and columns as well. Let us check. So how do we first we'll create an array, I mean the matrix. So now I'll create a 3 by 3 matrix, 3 rows and 3 columns. Okay, I'm printing this out. Okay, listen carefully, guys, because the slicing is the most crucial part. So whenever you want to slice the data while dealing with data science algorithms and all, you slice it. You slice it in this way only. Okay. 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 See, if you want to slice, if you need only 4 comma 5, I'm just telling you, like in between value I've taken, I want only 4 comma 5 value. So how I'm going to slice it? Okay. First, the slicing is same for all. Like we use square brackets for slicing. That's common. But yeah, so for multidimensional slicing, we have two parts. One is row and the other one is column. So first we'll concentrate on row first. So in which row does the 4 comma 5 is present? Second row. Second row, right? Second row, what is the index position of that second row? That is 1. Perfect. That is 1, right? So we got a row value now. We'll keep a comma. That means you have selected the first row inside that matrix. So we have selected first row in the sense the index position 1. That means the second row. We have selected the second row inside that second row of that matrix. And now you want the values 4 comma 5. 4 comma 5 belongs to 0 column and 1 column. I'm talking about the index now. So 4 comma 5 belongs to first column and second column, and the index positions of those columns are 0 comma 1, right? So what I'll do, 0 is to, I'll place 0 is to 2 here. That means 0 and 1 will be selected. Okay. If I run this, see, I've got the slice data now, 4 comma 5. So while doing the multidimensional slicing and all, what you need to do is you take this number, the initial number that is considered as row, and after the comma, what are the numbers are there, that the matrix considers that as columns, and it slices the data. Yeah, so that's how you do it. And anyone can tell me, if I want 7 comma 8, what could be my input? Anyone? If I want 7 comma 8, what could be my input here?
1,
1, 0
1
ish.
comma 0 is to colon
B.
3.
1 comma 0 is to colon 3. Okay, that's wrong.
Colon 3.
Yeah, that's wrong actually. See,
2,
understand. Yeah, so 2 comma is right, because first you need to understand in which row the values we want. So like second, so index position, you need to take the index position, right? 0 comma 1 comma 2. And if you want 7 comma 8, use 0 is to 2 only, because Python excludes the last number. It considers 0 and 1. See, I got 7 and 8 value. Okay,
Sir,
what if?
why you are using 0:2?
Okay, so there are 2 elements here, right?
Yes.
So this is column 1 and this is a column 2, right? This is column
Yes.
1 and this is column 2. So for the first column, the value is 0, the index position. For the second column, the value is 8, right? So there are 2 columns now. 0 comma 1 should be, we should get it. So each 2, what it does, it takes that range now. So that's what we have learned in lists and all. Remember, we use each 2
Yes.
for that range and all. So it
Yes, yes.
considers 0 and 1 and it excludes the 2 value, and that's how we get the output. Okay, again, one more question to you guys. Like, I need 5 comma 8 now. This 5, this 8. So how we are going to do it? Understand it properly. Understand the logic. I mean, at first it's very complex only, but after understanding that, it becomes very easy for you. I need the output to be as 5 comma 8. So what could be my input?
1, comma 2.
5 comma 8. Remember. So 1 comma 2. So if I keep 1 comma 2, what could be the output? Is the output 5 comma 8?
No, sir.
No, the output is not 5 comma 8. See, it has given you 6. I need 5 comma 8 value. So what you're going to do it? So first consider, like, in which rows 5 comma 8 is? Can you tell me in which rows 5 comma 8 is by using the index number?
1, 2. 1, 2.
1, 2, right? So I need to keep 1 is to 3 for rows, because I need 2 rows now. Comma, in which column the 5 comma 8 values are there?
Second
Second
column.
column.
Second column, that means index
Index
position is 1.
1.
See, 5 comma 8. Okay, remember, like how many rows you are selecting or how many columns you are selecting. Now, based upon that, you need to use this is to format. I mean the colon format. Okay.
Sir, repeat once, sir. Could you please repeat once?
Sure, I'll repeat it. That's okay. Don't get confused, guys. It's very simple. See, you need to understand in which row the elements are present and in which column the elements are present. That's it. Okay. The first thing. So first we'll start with the 4 comma 5 value. If you see this, in the second row, the 4 comma 5 values are present. That means in the first index position. So 1 I have given it here. That is done. I kept a comma. That means we are separating the rows and columns now. To the left of the
Excuse me,
comma.
sir.
Yeah, please.
That index position is for whole row, sir.
Yeah, this whole row, no? Yeah, that's what. This is the first row, this is the second row, this is the third row.
Yes, sir.
Yeah, index position is for the whole row. And from the top, index position is for the entire column. Remember that, okay? Okay, yeah. So I have chosen this first row, index position 1, and then followed by 0 is to 2. That means 4 comma 5, I need the values, right? So the columns, the 0th column and the first column has got the values which I want. So I'll use 0 is to 2. 2 will be excluded in Python, and that range will be taken. It will be considered, that range will be considered, and it gives me the output of 4 comma 5. Okay, if I want 5 comma 8, if I want 5 comma 8, what I will do is I'll see in which rows the 5 comma 8 is present. So 2 rows are there now. So I need to like give the range here. 1 is to 3. That means 1 and 2. The index positions of 1 and 2 will be considered. And inside that index position, the column value, second column, take the values of the second column. That is 1. Are we clear? Are we clear, guys? Okay. So tell me one more thing. I want this 3 6. What you will do? 3 6. I want this 3 and 6. What you are going to do?
2 is to 2, comma.
Okay. Think carefully. 3 6. Okay. I'll ask you a question so that based upon that, you give me the answer. Like
0:2, sir.
0 is to till where? Till which row? Till 2, right? It considers 0 and 1. Are we clear? It considers 0 and 1. That means 0 row and 1 row are selected. And in which column the values 3 and 6 are there?
Third.
Third column. That
Third
means
column.
the index position is 2. It's 0, 1 and 2, right? See, we got 3 and 6. Okay, your homework for today is like create like at least four rows and 4 column matrix, and slice it like whatever the number you want out of it, no, like sequence, like 5 comma 6, 2 comma 3, 4, 7, whatever you consider that, and slice it. At least slice 5 times. 5 times you take the input and try to understand how the logic is working and get the output. Okay. Yeah, we are good. Okay. And we have stacking in picture. Stacking combines the arrays either in horizontal way or in vertical way. Yeah. So previously we are not having that concatenation thing. Remember? So in NumPy we don't have concatenation. Here, we can stack it. Like we can place one array on top of that array either horizontally, or if you want to place the array beside that array, you can keep it. I mean, either horizontally you can work on, beside, either vertically on top you can keep it. Okay, let us understand this function first. So np a range of 6. Okay, so if you're giving 6, the initial value is not there, that means it considers the 0 value. Remember that. So that means 0 to 5 numbers are created, and we are reshaping it 3 comma 2. Okay, that means 3 rows and 2 columns are created. So let us use the same function. I'm copying it, and see, if I print a, see 0, 1, 2, 3, 4, 5. So till 5 we have printed the values in the array, and with the shape 3 comma 2. Right. So we'll take another array, a range from 6 comma 11 dot reshape 6 comma 12, because we need 6 elements, right? So reshape, because stacking also is done based upon your size only. So if the size is not same, then definitely will throw an error. Okay, like I'll print a comma b. See, so this is a matrix and this is b matrix we have. Okay, now if I want to stack the things up, stack in the sense like on vertical stacking, if I want to do vertically, so a comma b, use this syntax, np dot v stack of a comma b. That's it. I'll go here. Okay, sorry. So it needs a tuple, for the shape and all the input. Okay, see, so vertically the stacking is done. 0, 1, 2, 3, 4, 5 on to the bottom, 6, 7, 8, 9, 10, whatever the other values are there, it has done it. If I use h stack, horizontal stacking, see, it stacks the data side by side. So np.vstack and np.hstack. So horizontal stacking is done and vertical stacking is also done. In the same way, we have splitting function. Okay, splitting splits the array. Yeah, splitting splits the array into equal number of pieces we desire. Okay, can some, yeah, please mute now, guys. Yeah, so np.arange of 30. I'll take this. Now what's happening here is I'm taking 30 elements down here, and I'm reshaping that entire 30 elements into 2 comma 15. Let us see. Let us assign a variable and let us print it and see. So from 0 to 30 it is done. I mean, the elements are generated with this shape actually, 2 comma 15, 2 rows and 15 columns, right? Yeah, we are good. So now if I want to split horizontally, a comma n, like in how many splits you want to do also you can give here. The n value is that, and this is the array, and this is the function. This function has these two parameters. A is the array and n is how many splits you want to do horizontally. So let us check that. np dot h split array, and then followed by, suppose 3. If I want to do 3, see, it has split down the entire array into 3, right? So if you want to do 4, see, it can't do it because Array split does not result in an equal division. See, it is not equally dividing. That's why it is throwing you that error. Yeah, that's why it is showing us that error. So whenever it has the equal number of pieces only, it divides it. If not, it will not divide. Okay. And if you want to do vertical splitting, see, 3 splits are done horizontal: 0, 1, 2, 3, 4, and then 15, 16, 17, 18, 19. So this block it has taken, and this block, and after that the last block. What happens if you do vertical splitting? See, we split now. Whenever it is doing V split, there is no equal division for it. That's why it is throwing us that error. What happens if you take 5 also? It's not working. Yeah, only 2. Since there are only 2 rows, it can't divide equally, no? So that's why the vertical splitting is throwing up that error. So 2 rows can be splitted like into 2 only, right? Maximum 2. See, it has splitted that entire data into 2 now. So that's how, you know, split. You can split the entire matrix also. It's up to us. You can split the matrix into multiple ways, and you can take that portion of data only, play with the data, and something you do some operations on that particular data, and again you replace it back. You place it back. It's up to us. Okay. The next thing is Boolean arrays. Boolean gives true or false values in an array according to the condition. For example, yeah. So let us consider this array. Okay. So Booleans, you know, while dealing with Booleans, yeah. Oh, sorry. Syntax error. Yeah. So while dealing with the Booleans, so whenever you give some conditions to the array, it automatically checks whether it is true or not, and it gives you that output. For example, if I'm giving it a is less than greater than a is less than 5, it goes with each and every element. Like 1, it checks for 1, no, 1 is less than 5. If the condition is true, it throws you the true value there directly. If the condition is false, it throws you the false value directly. See, so 1 is less than 5, it's true. 2 is less than 5, it's true. 3 is less than 5, it's true. 4 is less than 5, it's true. 5 is not less than 5, and 6 is not less than 5. So that's why there are 2 false values and 4 true values here. Until and if the condition is true, then it gives you true value. If the condition is false, then it gives you the false value. Those are called as Boolean arrays. Okay, and this thing, you do this as a homework, iterations now. So you try to understand like how the enditer works, you know, enditer works, and how you iterate over the arrays and all. Okay. Okay, so look at this, guys. See, I don't know how many methods are there in NumPy, but we have covered like most probably not all, but few parts of methods. But where did I get these method names? How did I search for it? It's simple. I'll go to the, I told you, each and every package has got its own website, official website. See, so if I type NumPy in Google, see, there's official site here, numpy.org. I'll go here, and I can go for the documentation here, and absolute beginner's guide. Yeah, I can go here. Welcome to NumPy. Install NumPy. See, array engine. There's so many methods out there, but I've picked only few. And because, see, again, I can't teach you all the methods here because there's so many methods out there. More, I don't know, like it might be hundreds and everything. We can't discuss all the methods here, but I'm making you to habituate to the methods and all. Understand that how to create methods, how to create functions, and how you can use methods, how you can check the documentation and all. Okay, see, there's so many functions, a linear space. You can do whatever, like you go to this documentation and try to identify at least 5 more methods which I have not told you, and understand how the methods are working. That is your homework. Identify 5 more methods in the official documentation of NumPy and understand how the methods are working. Like complete that, like do the coding part there. Clear? And work on these iterations as well. Take a screenshot of it. Yeah, and you can work as a homework. Good. Okay, so in the after the NumPy and all, you know, we have Pandas also in picture. So Pandas is also an important package in Python. While dealing with data science and all, no, we come across this Pandas very often. Like we use it. Like NumPy we use it, Pandas also we use it. Okay, so what is this Pandas package do exactly? So in computer programming, Pandas is a software library written for the Python programming language for data manipulation and analysis purposes. So that's why data scientists use Pandas more. That means you can do the data manipulation part, and you can do the analysis part as well. Analysis in the sense like you can represent that in the form of graphs or something, or you can perform mathematical operations directly, like you're getting right. So I told you like data is present in different files, actually different formats. Some people store data in the form of excels, some people store the data in the form of log files and all, so there's so much of file formats, where you can store the data. So we take that file formats and we convert that into a neatly organized format by using these pandas, and we manipulate it. If you want to manipulate, you can manipulate the data, or if you want to do the analysis part, you can do the analysis part as well. Okay, so first we'll take a basic example. Like pandas can read a CSV file by using read CSV. Yeah, so I'll take a CSV file. So I hope everyone are aware of CSV files, right? It's an Excel file only, but it is stored in the form of .csv, comma separated values, we call that as. Okay, first let us take one CSV file. Okay, I have a CSV file here. Okay, so I have a CSV file, and let us paste the CSV file in our Hyse folder. Yeah, I pasted my CSV file here. I'll just stock. I'll simply type stock. So I guess everyone are aware of stock market and all, right? So this is the data of a stock. This is the data of a stock. Okay. See, from 9:15, 9:20, 9:25, this is a 5-minute interval. See, I'm analyzing the data. See, we need to understand what data is talking with us. That's what I was telling you, right? See, by looking at the data, what I can see is there's a 5-minute time interval gap between one data point to other data point. And there are 3 values here: open, low, and close. Open, low, and close are there. We have 3 values, and each row has got its own open, low, close value at that particular time frame. So this is the thing what data is talking with me, like what it is representing and all. I'm checking it. Okay, now I'll try to get this data into my Python environment. Okay, to get the data into my Python environment, definitely I'm going to use pandas now, right? Pandas is responsible for that. Pandas is a package where you can import your files neatly into the Python environment. I'll show you. I'll first import the pandas. I'll give some shortcut name to it, import pandas as pd, and then I'll use a data frame, df. So df is a data frame. Data frame, what do you mean by data frame? Data frame is something which is represented in the form of rows and columns. That's it. So here, pandas uses the data frame, like it represents the entire data in the rows and columns, and that is called as a data frame. So I'm just replacing that with a shortcut name, that is df. And in order to call a CSV file, this is the syntax: read underscore CSV, and then followed by the file name. So what was the file name? Stock.csv. Okay. Okay. We'll print the data frame and just check. We'll check the output. See. So the entire data which is present in our Excel sheet has come into our Python environment. Now you can play with the data. Like you have the data in your Python environment and you can play with the data. For example, see, if I want to like open close, I want to know how many points it has moved at this particular time frame, 9:15. Are you getting it? So the analysis you need to do in this way. You need to understand what data is talking with us. See, at 9:15, how much it has moved? What is the open and what is the close price? That means it has moved like from 9:15 to 9:20. It has moved from this point to this point. But how many points? I need that analysis now. So for that, what I will do is simply I'll create a new column. For creating a new column, simply understand this difference. I'm just giving the column name. So df of quotation difference is the new column name, and what you want to do with that new column name, let us see. So df close minus df open. Okay, I'll print df now. Okay, can you see here, guys? See, so difference, the close and minus open. So the values are here. That means at 9:15 it has moved to 9 points, and immediately at 9:20 it hasn't moved that much, and it is falling back. See, -8 is the falling. It's falling, like it has opened somewhere, it has closed downwards. That means the market is falling. See, the market is falling. Market is falling. Whenever you get those negative values, that means you consider that the market is falling. Whenever you get the positive values, that means you consider that the market is moving upwards. Okay, this is one kind of data I'm showing you. Like this is like stock market. I have taken the data and I'm explaining it to you. but different domains will have different sets of data. You need to understand what the data is talking with you. For that, you need to do the analysis part. So this is whatever we are doing is the manual analysis part. Like we are just randomly checking how the data is and all. Okay. Yeah, so that's how you can manipulate. Like I have manipulated it here. In the same way, if you want to apply anything, any mathematical equation, you can apply it. So we'll look into it. Okay, so before that, okay, let us close this and we'll come to our original data frame. Yeah, we have our original data frame, and if you want to know how many columns are there, like you want only the column names and all, then just type df.column. See, it has 4 columns: date, time, open, low, and close. Okay, and if you want to know how many rows are there in that, use df.shape. 450 rows are there and 4 columns are there. Date, time, open, low, close, 4 columns, and 450 rows are there. That means you have 450 data points now in this file. So it has automatically read all the data points within instant, right? At a glance only, it has understood like how many rows are there and how many columns are there. Yeah. So that's how pandas are used very widely. Pandas are used very widely to understand how the data is and what data is talking with us, and yeah, how to manipulate the data and all. Also, you can do it. Okay. Yeah. So for accessing columns, we use this syntax df of column name. It's very simple, right? So what I'll do, if you want to access only the close column, I want only the close column. I don't want all the columns now. See, it has given me only the close column values. Name, close, the column name, close, and the length is 450, and it has given us the data type as well, float. Right? So that's how you can access the columns, like df of close. By using that, now you can access the columns as well. Finding maximum value or minimum value among that column. Like if you want to understand, if you want to find the maximum value, simply use dot max for that particular column. See, you got the maximum value. That means this is the maximum value for that particular day or for that particular week, something like that, for that stock. So that's how you can identify maximum values also, minimum values also. It's very easy for us. Pandas has given us that essence, where you can find maximum or minimum or any mathematical operations, very easily. Okay, I guess we are good for today, guys. Like we are good for today's session. Practice the homework, and yeah, I'll stop the recording.